this episode, we focus on a simple but powerful idea. Many security problems never need to happen if you design the system, so there are fewer ways to get hurt in the first place. That is what reducing attack surface means. For AI systems, attack surface includes every path where data enters, every place the model can be called, every integration that passes outputs downstream, and every component that stores prompts, logs, or model artifacts. Beginners sometimes think security is mostly about defending against attackers after a system is already exposed, but good security architecture also prevents exposure from becoming unnecessary. Smart deployment and integration choices are about deciding where the AI capability should live, who should be able to reach it, what it should connect to, and what it should never touch. When you reduce attack surface, you lower the number of doors, windows, and hidden tunnels that can be used for misuse, mistakes, or attacks. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. To understand attack surface in a beginner-friendly way, imagine a building with many entrances. If the building has 10 unlocked doors, anyone can try to get in 10 different ways. If the building has one guarded entrance, entry is easier to control, monitor, and protect. In technology, each exposed endpoint, integration, or access path is like a door. In AI systems, doors are not only network connections, but also API calls, plugins, data connectors, admin consoles, and even workflows where people copy and paste data into a model interface. Reducing attack surface means you eliminate doors you do not need and strengthen the few you do. This does not make you invincible, but it makes security more manageable because you are protecting fewer points and you are more likely to notice when something unusual happens. Deployment choices are one of the biggest drivers of attack surface because they determine where the system runs and who can reach it. If an AI service is exposed broadly to the internet, the attack surface includes the entire world of potential users, including malicious actors. If the same capability is restricted to internal networks and approved identities, the attack surface shrinks dramatically. Another deployment choice is whether you separate environments, such as keeping development and testing isolated from production. If the training or testing environment can reach production data or production services, you risk accidental exposure and easier paths for attackers. Keeping environments separate is a deployment choice that reduces attack surface by limiting what any single compromise can reach. For beginners, the key is to see deployment as a security decision, not just an operational convenience. Integration choices matter just as much because integrations create pathways that can carry risk from one system to another. When an AI model is integrated into many applications, each application becomes a potential entry point and a potential leak path. If one application has weak access control, an attacker might use it to reach the AI capability. If one application logs data poorly, sensitive prompts might end up stored in insecure places. Integrations also create complexity, and complexity often produces gaps in understanding, which attackers and accidents exploit. Smart integration choices are about limiting where the model is embedded, standardizing how calls are made, and avoiding one-off connections that bypass normal controls. A smaller number of well-governed integrations is usually safer than a large number of ad hoc integrations. One practical way to reduce attack surface is to control how users and systems access the AI capability. Instead of letting every application connect directly to the model, you can route access through a controlled interface that enforces identity checks, input validation, and logging. You do not need to picture a specific product to understand this. It is the idea of a single controlled gateway rather than many scattered direct connections. When access is centralized, you can apply consistent rules about who can use the model, what kinds of requests are allowed, and how usage is monitored. Centralization also makes it easier to update controls without chasing changes across many teams. For beginners, this is the same logic as having one front desk for a building rather than 10 side doors with separate keys. Another smart deployment choice is to limit data exposure by design. AI systems often become risky when they are given broad access to sensitive data sources, especially if the model can retrieve or summarize content from internal repositories. If the model has access to everything, a user might unintentionally request sensitive information, or a malicious user might try to extract it through repeated prompts. Reducing attack surface here means limiting what data the AI system can see, limiting the scope of retrieval to approved datasets, and minimizing how much sensitive context is passed into prompts. Even when data access is authorized, less exposure means fewer opportunities for leakage. This is not about making the model useless. It is about giving it only what it needs to do its job and nothing extra. It is also important to think about outputs as part of attack surface, because outputs can trigger actions and spread risk. If a model's output is automatically used to make decisions, generate communications, or update records without review, then the model becomes a high-impact control point. Attackers might try to manipulate outputs by crafting inputs that cause the model to produce harmful or misleading results. Accidental errors can also propagate quickly if outputs are trusted too much. Smart integration choices often include adding friction where it matters, such as requiring confirmation or oversight for high-impact actions. The goal is to avoid letting model outputs become an unmonitored command stream into your business systems. When you reduce output-driven pathways, you reduce the ways the model can be used as a lever to cause harm. AI systems also have unique attack surface related to prompts, context, and logs. Prompts may contain sensitive instructions, user data, or internal policies. Context windows may include retrieved documents, customer records, or prior conversations. Logs may capture inputs and outputs for troubleshooting and auditing. Each of these can become a target if stored broadly or accessed by too many people. Smart deployment decisions include carefully choosing what is logged, how long it is retained, and who can access it. Smart integration decisions include avoiding unnecessary sharing of prompts and outputs with third-party analytics or debugging tools. Beginners should remember that a security leak often happens not in the main system, but in the side channels where data is copied for convenience. Another practical area is controlling administrative access and management interfaces. Management tools that allow configuration changes, model updates, access policy changes, or integration settings can be extremely powerful. If those interfaces are exposed too widely or protected too weakly, they become an attractive target. Reducing attack surface means restricting management access to a small set of approved identities and locations, using strong authentication, and separating responsibilities so one person or one account cannot do everything without oversight. It also means limiting how many people have direct access to model settings or deployment pipelines. When administrative access is tightly controlled, attackers have fewer high-leverage pathways, and accidental misconfiguration becomes less likely. A beginner might ask how to decide what to remove or restrict without breaking the system. The answer is to connect attack surface reduction to purpose. Every integration and exposure should be justified by a clear business need and should be designed so it does not create unnecessary pathways. If a connection exists only because it was easy to add, that is often a candidate for removal or redesign. If a system is accessible to many users, but only a small group truly needs it, that is a candidate for stronger access restrictions. If an application can call the model directly, but there is no consistent monitoring, that is a candidate for centralized access control. The mindset is to treat access and integration as privileges that must be earned by necessity, not defaults that grow without limits. It is also important to recognize that reducing attack surface helps both security and reliability. Fewer integrations can mean fewer breakpoints when updates occur. Clearer deployment boundaries can make troubleshooting easier and prevent failures from spreading. More centralized control can make it easier to apply changes, enforce policies, and respond to incidents. This is why architecture and security are linked, because good architectural choices often improve both safety and operational stability. Beginners sometimes view security as an obstacle, but attack surface reduction is often a way to simplify the system, which can make it easier to build and maintain. When you present it that way, security becomes part of good engineering rather than a separate burden. As you keep learning, you will see that attack surface reduction is not a one-time event because systems tend to grow. New integrations get added, new data sources become available, and new user groups request access. Over time, that growth can quietly reintroduce risk if it is not governed. A good security architecture includes a habit of reviewing new deployments and integrations through a risk lens before they are approved. That does not mean stopping innovation. It means shaping innovation so it does not create unmanaged exposure. When teams know that every new integration must be justified and controlled, they are less likely to create shadow pathways that bypass security. To wrap up, reducing AI attack surface through smart deployment and integration choices means you deliberately limit how many ways the AI system can be reached, what it can access, and what can happen to its outputs. Deployment decisions, like restricting external exposure and separating environments, shrink the number of potential entry points. Integration decisions, like standardizing access paths and avoiding ad hoc connectors, reduce complexity and prevent control gaps. Limiting data exposure, protecting prompts and logs, and restricting administrative interfaces reduce the most sensitive pathways that attackers and accidents can exploit. When you understand attack surface as a design problem, you gain one of the most effective, beginner-friendly security strategies available. If you do not create the doorway, you do not have to defend it later.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.